Algebra 2 skills, number 32, cube root graphs. So let's again remind you what a definition of graph is. Graph is simply a picture of all solutions to a particular equation. So if we have the equation y equals the cube root of x, again, this is going to be our parent because there's no adding or subtracting or multiplying or negatives going on. This is your graph. So you notice that it looks a lot like a square root graph if you've seen those, but it goes in both directions. Particularly, the cube root of 8 is 2, the cube root of 1 is 1, the cube root of 0 is 0, but these negatives, the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. That's why a cube root graph goes both directions, but a square root graph would abruptly end here. It's because a square root, if you take a square root of a negative, you get an imaginary number which doesn't show up on a graph. So that's why we have a two-sided graph as opposed to the one-sided square root graph. Domain and range. All x values covered by a graph is the domain of a graph. You've probably know this at this point. It goes leftmost to rightmost. Range are all y values covered by a graph. They go lowest to highest. So the instructions here to graph and tell the transformations from the parent and provide the domain and range. Okay, so here we have y equals the cube root of x plus 3. Okay, you're simply adding 3 to the outside, and that's going to make the graph go up. So notice again this two-sided graph. The red is the parent that's used for comparison purposes. The actual graph is the blue one, but notice that this middle point and every other point as far as that's concerned goes up 3 units. That's because of this 3 here. That's a vertical shift up 3. The domain and range here are just all real numbers, negative infinity to positive infinity. The domain is such because it goes left forever and it also goes right forever. There's no restrictions. The range is that way because it goes down forever and up forever. And if you're familiar with interval notation, you know that infinities always get parentheses here. Let's take an example of the same instructions. A little bit more going on here. We'll take a look at it. Actually, first we'll look at the transformation this time. It's a vertical stretch by a factor of 2. That's because you're multiplying by 2. We'll see what that does in a minute. Horizontal shift right 4. Remember, you change the sign on the inside, or it's maybe opposite of what you think on the inside. And vertical shift up 3. The domain and range, as you might expect, is still negative infinity to positive infinity. And then looking at it, again, we have our parent here. That's the red. The blue one looks quite different. Same basic shape, but you can see it's stretched out. It's taller. It's like someone grabbed it and pulled up on it. So that's where the vertical stretch comes into play. The horizontal shift, again, if you focus kind of on this middle change of direction point, it goes over 4 from the origin, whereas it also went up 3. So over 4 to the right and up 3. So cube root